So again, we had x squared minus 6x minus 19 equals 0. The middle coefficient, I divided by 2, and I square this number. And this is the number I have to add to both sides. Because here, when I square, I get the first term squared, minus 2 times the first times the second, plus the second term squared. I move 19 to the other side, and 19 plus 9 is 28. Now I can take the square root. I cannot take the square root if I have a sum or a difference under the square root. Now I can take the square root. I write x minus 3, and from here I have the plus or minus. I have to split 28 into 4 and 7, so I can simplify the radical. And I have 2 to the square root of 7, and then I insert 3. So 3 plus or minus 2 to the square root of 7. Is this okay?
Yes, thank you.
Thank you. Okay. This is the quadratic form, the Pythagorean theorem. 1 squared plus 4 squared equals x squared. 5 squared plus x squared equals 13 squared. So always the sum of the squares of the legs equals the longest side squared. So the length of the legs, and they want us to find the hypotenuse. Okay, is there anything else in 8.6 before we look at 8.7? If you want us to work on any of this, let me know. So here we have the legs, and we want to determine the hypotenuse.
I think the next one of the next one is like a tree or something.
Let's take a look.
Yeah, this one.
Excellent. Let's take a look. Very good. So Pfeiffer has a 14-foot ladder. This is the hypotenuse. He places the ladder 6 feet from a building. Okay. Oh, I didn't mean to save. Okay, fine. I don't know. I hope I didn't mess it up. Okay, so he places the foot of the ladder 6 feet away from the building. And his ladder is 14 feet long. Let's read the problem one more time. It says,
See, I didn't know that was the hypotenuse. I thought that was just the height of
but
the
imagine
ladder.
how do you get up? If he placed the ladder 6 feet from a building, right? So it has to be the hypotenuse.
Okay.
Right? Because he walks here to get up. So he placed the foot of the ladder here, 6 feet away from the building. So here's the building. And he places it here, and he goes up. So we want to know how high will the ladder reach on the building. And of course, you have to write that one leg squared plus the other leg squared equals the hypotenuse squared. So please don't remember the Pythagorean theorem like a squared plus b squared equals c squared. No. The sum of the two legs, because the right angle is right here. So the sum of the squared of the legs, the sum of the legs squared equals the hypotenuse squared. So all you have to do is do this. 14 squared minus 6 squared. And you don't have to do this with a, you have the graphing calculator, you are allowed to use it. And here it is. All you have to do is plug in 14 squared minus 6 squared, which is we know is 36. So the answer is 160. So x squared equals 160. Well, 160 is not a perfect square. And you can say take the square root from both sides and write plus or minus. Okay. So this is 16 times 10. So it's 4 to the square root of 10, but I will cross it out. and say only x equals 4 the square root of 10, because we are talking about the distance. And if they want us to approximate it, which I will not tell you I have in my pocket, $4 and the square root of 10. So normally they want an approximation on something like this. So I will put the square root on 160 and just get 12.65 feet. And the measurement unit has to be there. Round to the nearest tenth. Say, oh, they only want one digit. So in that case, if they only want one digit, I would say 12.6. Because the next digit is 4, not 5. Good. Let's look at 24 and see if there is anything. It's the same idea. So the two legs of a right triangle are N and P. Okay. So the hypotenuse is Q. Fine. Solve for N. Good. Let's do this together. Because, so this is N. Here's the 90-degree angle. Here's Q and here's P. And they want us to solve for N. Very simple, because once I write the Pythagorean theorem, N squared plus P squared equals Q squared. Remember, you cannot take the square root. This will be a terrible, absolute terrible mistake, because you cannot apply the square root to a sum. You cannot do anything here. But if I'm solving for N, I will move P to the other side. So N squared equals Q squared minus P squared. Now I will apply the square root, but I cannot take the square root. And this time I will not write plus or minus, only because N is a distance. So I will write a square root of Q squared minus P squared, and do not attempt any simplification. We do not have any formula for the square root of a difference of terms. This is done and over with, carved in stone. We have no formula for taking the square root of a sum of terms or a difference of terms. This has to stay as is. Good. Okay, so let's go to the last section, 8.7. 8.7, practice. Okay. I created a retake for test 3. Nobody's obligated to take it. You take it if you want to. If it's higher, it will replace your previous grade. If it's not higher, it will not replace anything. It's up to you. You have today, tomorrow, and Thursday. Okay, so we go back to 8.7. Well, let's see what we need from 8.7. Write the equation in standard form, and then identify the values or A, B, and C. Write the equation in standard form, then identify A, B, and C. Do not solve. You stop me when you want to. Solve the equation using the quadratic formula. Quadratic formula.
Can we do that one?
Yes, of course. I'm going to use x. So 3x squared equals negative 2x plus 2. Good. So we cannot use the quadratic formula before we arrange the equation in the standard form, meaning 3x squared plus 2x minus 2 equals 0. So this is the starting point, because only here I can identify that A is 3, B is 2, and C is negative 2. If it's not in the standard form, we cannot correctly identify A, B, and C. So now in the quadratic formula, all I have to do is write negative b plus or minus b squared minus 4ac 4. A times C is 6, and it's minus, so I'm going to change this to plus over 2A. Negative B plus or minus B squared, plus or minus the square root of B squared minus 4AC over 2A. Any questions so far? Okay. Negative 2 plus or minus 28. 6 times 4. I have to multiply first. 24 plus 8 plus 4 is 28. And we just simplify the square root of 28 as 2 the square root of 7. Attempting to simplify 2 with 6 will be terrible. A terrible mistake. But if I factor out the 2, negative 1 plus or minus the square root of 7 divided by 6, now I can simplify. So the simplified form is negative 1 plus or minus the square root of 7 over 3. Any questions? Any questions on the quadratic formula for this problem?
No, thank you.
Perfect. Anybody else? Before
Oh,
we
unless you did, Janelle, sorry.
That's okay. I was just trying to figure out how you got the negative 1.
negative b. Negative b. And then 2 times negative 1 is negative 2. 2 times plus or minus the square root of 7 is 2 the square root of 7. If I don't put anything here, I started with 2 terms and I ended up with 1. That will be a term.
Oh, okay. I see it. Thank you.
Thank you. You remember, if you start with 2 terms, you have to have 2 terms in parentheses. Otherwise, when you try to check your work, you will not have anything to distribute to. How do you get this term? Good. Moving on. So the equation is a quadratic formula. Quadratic formula. Okay, this is important. Let's work on this one together. Match each discriminant with the appropriate description of the solutions. One real number solution. That can happen only when the discriminant is 0. However, it is a 2 real number solution, but it's a double solution. Okay? But that's the discriminant is 0. Now, 2 different real number solutions. So this one is 2 real number solutions because we have the plus or minus 1. This one also, because we have plus or minus the square root of 8. This one also. So I'm not sure what they're trying to do here. So this is real. 2 different real number solutions. And this is also here. And these are the complex solutions because you have to take the square root of a negative number. See if it's clear before I click on final check. So when the discriminant is 0, we get 1 real solution, but however, in our minds, we know it's a double solution. Quadratic equation cannot have one solution. Can have one solution that repeats twice. then whenever I can take the square root, I can take the square root of 1, I can take the square root of 8, I can take the square root of 9. I have two different real number solutions. When the discriminant is a negative number, the solutions are two different non-real. There is no reason to write non-real and then complex. If you say non-real, it's enough. If you say complex, you don't have to say non-real. It makes no sense to use both. But that's okay. That's how they present things. But if you say non-real, you have to stop. Or you say two different complex number solutions. You don't have to say non-real and complex in the same word, in the same sentence. There is no need. Determine the discriminant and then identify what type of solutions. Okay? Determine the discriminant and the type of solutions. Calculate the discriminant and the type of solutions. And determine the type of solutions. It's all based on what we just find the discriminant and then identify the solutions. There's no reason to say two complex solutions that are not real. You don't need to say this. You either say two complex solutions, full stop, or you say two non-real solutions, full stop. There is no need to have complex and non-real in the same sentence. Okay, how would you solve this equation? Will you solve it by factoring, quadratic formula, or square root? Meaning the question is really saying which is the best method, the fastest and the best method to apply here.
Quadratic?
Quadratic, of course. Factoring, I have 6, so it's 2 times 3 and 1 times 6, I will never get negative 10. Take the square root principle, I have to complete the square. Exactly. So the best method here and the quickest is the quadratic formula. Okay, and then it's asking us to find the solutions. Oh, yes, yes, yes. Okay, what about here? Which is the best method to apply here?
Square root?
Absolutely, absolutely. It's already set up. Absolutely. It's set up. I don't have to do anything. I just have to put the square root on top of both sides and I'm done. Okay, what about here?
Quadratic?
Never when the free term is missing. When the free term is missing, never, ever, ever. You just factor out x and you're done. You factor out the greatest common factor and you're done. It's a waste of time. Can you apply quadratic formula? Of course. Is it wrong? No. But it's not the method you need here. You just factor out x and you get x equals 0 and x equals negative 10. It just takes a blink. What about here? Anybody? Any ideas?
I had to step away.
That's okay. Anybody can help with this? Anybody?
Is it the square root
Of
principle?
course, it's already set up. We're done. Takes a blink. Thank you. This is just solving some equations, of course, using the quadratic formula. You set them equal to what they give you, and then you set it up. Okay, I would like to work on, this is the same problem, 19 and 20. I would like to work on A, for example. I want to show you something else.